Hi, in this video we're going to learn how to identify polynomial function as odd, even, or neither. As a simple graphics, to easily identify that the polynomial function is even, it should be symmetric about the y-axis. If it is odd, it is the same when rotated 180 degrees about its origin. There are two ways of identifying a polynomial if it's either even, odd, or neither by looking at the graph. The second is algebraically. Let's start with looking at the graph. Even function is symmetric about the y-axis. As you can see, this is one graph, but both sides is like a reflection of the other. For an even function, for every point x, y on the graph, the point negative x, y is also on the graph. Or simply looking at the graph, if the graph is symmetric about the y-axis, then the function given is even. Now, odd function is same when rotated 180 degrees. Looking at the points, for an odd function, for every point xy on the graph, the point negative x, negative y is also on the graph. We cannot say it is symmetric on a certain way, but the easier way to describe it is that odd function is the same when rotated 180 degree. 180 degrees is that a half pi. Okay, not a complete revolution, it's a half revolution. Okay, let's proceed. Now, looking at your first example, graphically, looking at your graph, is this given an even, odd, or neither? Well, based on the definition, if a graph is symmetric about the y-axis, then it is even. Because it is creating a reflection over y-axis. Next, looking at the graph, if you put a point over the origin and when you rotate it, you have the same image, then it is an odd function. Let's try another. Now, if you put a point in the middle, or it is impossible that it will have a reflection over the y-axis, then it is a case of a neither. It is not the same when it's not a reflection over the y-axis, it's not the same image when rotated 180 degree, then it is a case of a neither, odd, nor even. Okay, so here is your summary. Looking at your graph, if it is symmetric about the y-axis, it is a case of even. If it is not symmetric, or is not the same image when rotated at the origin, it's neither. But if it's rotated about the origin and it's the same image, then you have the case of an odd function. So this is your main guide by graphical method identifying a function even if it is symmetric about the y-axis, odd if it is the same image when rotated about the origin, it's odd, or if that two does not apply, then that's a case of a neither polynomial function, neither odd, neither even. That's graphical method. Now, we could actually identify if a given function is odd or even or neither algebraically. Here are the rules. A function is even if we substitute a negative of x and it does not change the function, then it is even. A function is even if f of negative x is equal to the same function for every number x in the domain. A function is odd if we substitute a negative x and the function changes all the signs of its terms, then for every number of x in the domain, a function is odd if substituting negative x and all the terms changes sign. The third case, a function is neither odd nor even if both of the rules in the first case and the second case does not apply. Wherein when you substitute a negative x, it's not gonna retain the same function, or it did not change all the signs of the terms in the function. That is the case of a function that is neither odd nor even for all negative x in the domain. Let's have your algebraically method. If you plug a negative x into the function and you get the original function back, the function is even. Here's your example. Given function f of x is equal to 3x squared minus 10, and if we substitute negative x squared is actually positive x squared because negative times negative is positive. 3 does not change sign, so it retains, and negative 10 is not affected by the substitution, so we get 3x squared minus 10. Notice that it's the same. If you plug a negative x into the function and you get the original function back, the function is even. We have an even function. Let's have another example. So, is this function even? Well, if we substitute a negative x on each axis, negative x to the power of 4 does not change because it becomes positive. Because negative times negative is positive, negative times negative is positive. The same case here, negative times negative is positive. Then negative 2 does not change sign, 5 does not change sign, 1 does not change sign, everything did not change sign. It remains the same. Then it is even. Yes, the function is even. Let's have another example. Is this function even? If you substitute a negative x on each axis, negative x to the power of 3, negative times negative is positive, times another negative will make it negative. The 2 becomes negative. Negative times negative is positive. Actually, this becomes negative 2, this becomes a positive x. Both change sign, which is not the definition of an even function. Therefore, it is a no. No, it is not an even function. If all the signs change, it is actually the case of odd. Let's consider the definition of an odd function again. A function is odd if f of negative x is equal to negative of the function for every number x in the domain. Meaning to say, if you plug a negative x into the function and you get the negative of the function back, all terms change signs, the function is odd. Let's have an example. Here you have given f of x is equal to 4x cubed minus 5x. If we substitute all x's by negative x to the power of 3 is actually negative, so 4 becomes negative. Negative times negative is positive. 4 and 5 change sign. Then if all signs of the terms change according to the definition, if all terms change signs, the function is odd. Let's have another example. Is this function an odd. If we substitute negative x to the power of 4 actually does not change sign. Negative x to the power of 2 actually it does not change sign, so negative 2 stays negative, 1 stays positive, 5 stays, so nothing has changed. The function is actually not odd, it's actually uneven. So the answer is no. Let's have another example. Is this function odd? Well, if you substitute the negative on the x's, negative x to the power of 3 is actually a negative x, because negative x, negative times negative is positive, positive times negative is negative. 2 will become negative after performing this part. Negative times negative is positive. Both of the signs of 2 and the x changed. So, since all terms change signs, then it is, yes, it is an odd function. Okay, let's have your final examples. Determine whether the function is odd, even, or neither. If we substitute a negative x, this does not change, this does not change, this does not change, because power of even, negative times negative is positive. So since there's no change, this is the case of even. Let's have another example. Substitute all x's with negative. This changes the sign of 4, because negative to x to the power of 3 is negative. This becomes negative. Negative x squared to the power of 2 does not change. Negative 7 does not change. So there's a change on 4, but there's no change on x. It's either all signs changed or nothing has changed. If only one has changed, then it is the case of neither. Neither odd or nor even. Let's have one more example, and probably this is the last. If we substitute negative on the x's, this becomes negative, 12 becomes negative. Negative times negative is positive. Both signs change, all terms change sign, then it is definitely odd. That's it. Remember, if all signs change after performing a function notation of negative x, then it is an odd. If all signs did not change after performing function notation, it's even. If only some change after function notation of negative x, not all, then it's a case of neither. Neither odd nor even. Okay. You may review the video if you need to. Thank you.